Hello, welcome to 1.4, the complex number system. Okay, imaginary unit I is a value, and its properties. The imaginary unit I is defined as I equals the square root of negative 1. In other words, I has a property that its square is negative 1. I squared is negative 1. So square roots of negative numbers, if A is a positive real number, the square root of negative A would be I times the square root of A. You could factor out the negative and pull it out. It becomes I. Note that by this definition and by a logical extension of exponentiation, I times the square root of A squared is I squared times square root of A squared. I squared is negative 1, square root of A squared is A. So that's where you get that negative A. Example 1. Evaluate the following square root expressions. This would be square root of negative 12, like the square root of negative 1 times the square root of 4 times the square root of 3. Negative 1 is I, that's I times square root of 4 is 2 times the square root of 3, so it's 2I times the square root of 3. For B, we have the negative of the square root of negative 100, that's negative of the square root of negative 1 times the square root of 100. That's negative of I times 10, or negative 10I. We usually write the I last, or before a radical. We don't usually put the I after the radical because it may look like it's under the radical. For the next one, this would be like saying the square root of negative 1 times the square root of x squared. That's I times the absolute value of x, or absolute value of x times I. Either one of these. And D, we have the negative I squared. Well, that's negative I times negative I times what? Square root of negative 1 times square root of 64. So negative I times negative I. And negative times negative is a positive. We get an I squared from that. Times negative 1 is another I times 8. Now I squared is negative 1. So this is negative 1 times I times 8, or negative 8I. Complex numbers. Now we talked about imaginary. When it has an I, it's an imaginary number. Complex. For any two real numbers, A and B, the sum A plus BI, that is the sum of a real and a complex. Because once we put that I there, B times I is imaginary. That is a complex number. It's a combination of real and imaginary. The collection C stands for complex, equals A plus BI. A and B are both real. It's called the set of complex numbers. A is the real part, and B is the imaginary part. If the imaginary part is 0, then the number is simply real. If the real part is 0, then the number is purely imaginary. Okay, the powers of I. Well, I equals I. I to the 1 is I to the 2 is negative 1. I cubed. Now, what is I cubed? I cubed is I squared times I. I squared is negative 1. That's why this is negative I. I to the 4th is 1 because that's I squared times I squared. That's negative 1 times negative 1. That is 1. Over here I have this mistake on this part. So let me just rewrite the whole thing. First, I to the 4n plus 1 is I. I to the 4n plus 2 is negative 1. I to the 4n plus 3 is negative I. And I to the 4n plus 4 is just going to be something as I to the 4n, which is going to be 1. Now what this is saying is, if you can take that power and break it into, if you divide by 4 and the remainder is 1, you're going to have I. If you divide by 4 and the remainder is 2, you'll have negative 1. If you take the power divide by 4 and the remainder is 3, you have negative I. If you take the power divide by 4 and there is no remainder, you just have 1. Okay, simplifying complex expressions. Simplifying complex expressions: add, subtract, or multiply the complex numbers as required by treating every complex number, as a polynomial expression. Remember, though, that it is not actually a variable. I is not a variable. Treating a plus bi as a binomial in I is just a handy device. So to complete the simplification by using the fact that I squared is negative 1. So for a, we have 1 plus I, that's 1 plus 2i. Next we have I times the quantity 5 minus I, that's 5i minus I squared. It's 5i minus negative 1. It's 5i plus 1, which is 1 plus 5i. I to the 7th is going to be I to the 4th times I to the 3rd power. We know I to the 4th is going to be 1. I to the 3rd power is negative I, so we get negative I out of this. Negative of 5i cubed, that's going to be negative 5 cubed times I cubed. That's negative 125, and then I cubed is negative I. Negative times negative is a positive, so it's 125i. Go on to the next page. Or not next page. Bottom of this page. E. For E we have 5 plus I times 2 minus 9i. So we're going to FOIL that. 5 times 2. 5 times negative 9i. I times 2. I times negative 9i. That's going to be 10 minus 45i plus 2i minus 9 times negative 1. So that's going to be 10 plus 9 minus 43i. So it's 19 minus 43i. The last one is I to the 13th. So 4 goes into 13 3 times, with the remainder of 1. So think of this as I to the 4 times 3 plus 1. That's I to the 4 times 3, I to the 1. Well, I to the 4 times 3 is just 1. I to the 1 is I. So you get I out of this. Okay, so we have next thing is division of complex numbers. In order to rewrite a quotient, means fraction, in the standard form a plus bi, we make use of the following observations. A plus bi times a minus bi is a squared minus abi plus abi. The middle stuff goes away. Minus b squared I squared. Well, I squared is negative 1. Negative 1 times negative 1 is positive. So a plus bi times a minus bi is just a squared plus b squared. So given any complex number, a plus bi is the complex number, a minus bi is called its complex conjugate. So if you ever have 2 plus 3i, 2 minus 3i is its complex conjugate. Simplify the quotient of the two complex numbers by multiplying the numerator and denominator of the fraction by the complex conjugate of the denominator. Okay, so we have 10 over 3 minus I. So I multiply this by 3 plus I over 3 plus I. That's 10 times 3 plus I over 3 times 3. Well, we just know it's going to be, that's a minus b times a minus bi times a plus bi is going to be a squared plus b squared. So this is going to be 3 squared plus 1 squared. That's going to be 9 plus 1. That's going to be 10 down below. So the 10's divide out, and we're left with 3 plus I. Next one is 1 over 9, I to the 9th, 1 over I to the 9th. Now, I'm going to multiply this by I cubed over I cubed because I know if my power down below, or my power for I, is a multiple of 4, then we just have 1. So this is I cubed over I to the 12. So I cubed is negative I over, this is just 1. So it's negative I. Now we have 4i over 5 plus 7i. I'll multiply by the conjugate of 5 plus 7i. That'd be 5 minus 7i. That's going to be 4 times 5 minus 7i over 25 plus 49. And 49 is 74. And you can reduce that a little bit. Divide by 4, or by 2. You get 2 here, you're going to get 37. 2 times 5 is 10, minus 14i, that's 2 times 7i, over 37. Okay, the last part of this section, roots and complex numbers. Principal square root, given a positive real number a, the square root of a is defined to be the positive real number whose square is a. The square root of negative a is defined to be I times the square root of a. Okay, I need to move this up, so positive, you need more time to write that down. In simplifying radical expressions, we have made frequent use of the properties. Nth root of ab is nth root of a times nth root of b, and nth root of a over b is nth root of a over nth root of b. So the above properties must be for real numbers, or are for, the above properties must be for real numbers. So if we have non-reals, we must simplify them first. For example, square root of negative 9 times square root of negative 4. Well, that's 3i times 2i, which is 6i squared, which is negative 6. So we're going to, for example 4, finish off this section, simplify the following. 1 plus the square root of negative 6 squared. That's going to be 1 plus I root 6 squared. That's 1 plus I root 6 times 1 plus I root 6. Foiling, that's 1 plus I root 6 plus I root 6 plus I root 6 squared. That's going to be 1 plus 2i times the square root of 6. I squared is negative. Square root of 6, negative 1, that is. Square root of 6 squared is 6. So we end up with negative 5 plus 2i times the square root of 6. Next one. Square root of negative 98 over 3i times the square root of negative 2. It's like I times the square root of 98 over 3i times the square root of 2. So the i's can divide out. Now we have 1 over 3i, square root of 98 over 2. (98 over 2 is 49, so that becomes 7 over 3i. Well, we don't want a radical in the denominator, so I'm going to multiply by I over I. That's 7i over 3i squared. That's 7i over negative 3, so we can just say negative 7i over 3. And for our last one, we have the square root of negative 32 times the negative of the square root of negative 2. That's going to be I times the square root of 32 times negative I times the square root of 2. So we have negative I squared times the square root of 32 times 2. That's the negative of negative 1 times the square root of 64. That's 1 times 8, which is 8. That'll do it for 1.4. Send me your questions. Thanks.